Hello everyone. Today we are going to learn about Venn diagrams. This is lesson 2-5. Let's go ahead and get started. So Venn diagrams are very useful ways to show the relationships between things. And we can use our logical conditional statements and things like that to understand the connections between these. Now, if we look at some of these examples, the first one, we see a circle with a P in it inside a circle with a Q. And what that means is that every element that of P are also elements of Q. So all squares are rectangles, right? All squares being P, all are rectangles being Q. Make sense? So if we look at the second one, some elements of P are also elements of Q. So if there are some students that take band who also play football, if P is students who are in band and Q are students that play football, then that little area in the middle are students that play band and play football. And then if P and Q don't have any kind of interlocking part of the circle, then there's no relationship between P and Q. All of the elements of P are completely separate from all of the elements of Q. So let's go ahead and do a few examples. Some students who take chorus also take band. Well, this is kind of like the example we just talked about, right? Some students who take chorus also take band. So here, let's do this. We have a circle, and these are going to be the students who do chorus. And then we'll do this circle. And these are the students who do band. And then some of the students do both. So it's kind of referring to this little area here, if that makes sense. All right. So let's do another one. Numbers divisible by 6 are always divisible by 3. Now, anytime there's an always, then there's going to be a circle completely inside the other circle because it includes both. It's one of those all squares are rectangles kind of example. So here I'm going to make a big circle so that I have enough space. And these are numbers divisible by 3. And then it says all numbers divisible by 6 are always divisible by 3. So this is going to be another little circle, and these are going to be all numbers divisible by 6. And you see how that makes sense, right? Every number that's divisible by 6 is also in the bigger circle of numbers divisible by 3. And then let's do this. Some vertical angles are complementary. Well, you'll notice it says the word some. Some gives us the hint that there are going to be some that are and some that are not. So over here, we're going to have the elements of vertical angles, and over here, we're going to have the elements of complementary angles, and then this implies that these two are shared. Okay, perfect. So there's a few examples. If you want to do the even numbers, there's a few over there for you. So let's look at the logic of these, right? And let's use our conditional statements and compound statement notations. So you'll notice here that anything that is in P is also in Q. So we can actually use the conditional statement logic of if P, then Q, or even P implies Q, or however you want to phrase that, right? Now, let's look at the next one. You'll notice that everything is shaded. Think about what that could mean, right? It could mean that P is true, or it could mean that Q is true, because literally everything in those two statements are completely covered. So both of them, or either of them, could be true. So what this means is P or Q. Pretty familiar, right? So what do you think the next one is? You'll notice that in this case, both elements have to be filled in order for that little darker part to be filled in over there. So anytime you think of both as opposed to either, your ear should be ringing a bit. This is P and Q. Right? And that's kind of the logic behind this. So let's go ahead and do a few examples here. Now, let's think about what this means, and we'll do number 7 and number 9, and then you can try number 8. So first of all, the first one is just Q. So anything that includes Q is going to be correct. All right? So even though this area includes P also, these are just the areas of Q, and that's all that we're being asked, right? If this area also includes P, that's fine, right? That's what we're talking about. We're just talking about Q. So this whole thing is Q, and we are good. So what about this one? P and not Q. So remember, if it's and, they both have to be true, right? So not Q has to be true. So it can't be involved in Q. but it also has to be involved in P. So this little area here in the middle, right, that includes Q, but we have not Q, right? So we cannot include this part in the middle. So it is going to be all areas of P that do not include Q. And you'll notice I'm specifically not shading in that middle column because it can't include that because it's not Q. All right. Oh, well, I did number 8 anyway. Let's do this one. This one looks really fun. So P or Q and R. So first of all, what's the area that contains all of Q and R? Because the or isn't going to cancel anything out, right? It's going to just include everything. So Q and R, the only part that's true for that is this little area here where we have our Q circle and we have our giant R circle. So everything that includes Q and R is all of this here. And then it also says P and all of that. So anything that includes P is also correct. So I'm just going to include all of this because this is all of circle P, and this is all correct too. So the only part that isn't included is the part that's just Q and the part that's just R, essentially. Because it has to be, because this is an AND statement. Awesome. So if we wanted to do a couple statements now, let's do a couple of these. So let's do, so this one, remember, this is if then, right? So what this is saying is all beagles are dogs. All beagles are dogs. Cool. Easy enough. Number 13. So months that start with J and months with 31 days. So what this could be is this could say not all months with 31 days start with J. All right, awesome. And number 15, multiples of 7 and even numbers. This is just an or, so it's going to include everything. So some numbers I'm going to like include the word even here, so I'm just going to like insert even. Some even numbers are multiples of 7. And of course that means some aren't and some are, right? That's perfectly fine. All right, so that's it for Venn diagrams. If you have any questions, please let me know. You can also finish your check-in when you feel ready to go. But there are a few examples for you to do on here as well. All right, good luck, and I will see you next time.